So I think now it's time, and I'm happy to introduce our first speaker, Assistant Professor Heikki Nieminen, who is a leader of Biodesign Finland project, also innovator and research group leader at Aalto University, Department of Neuroscience and Biomedical Engineering. Heikki, what is the need-led innovation and why we should bother? Screen is yours.
Okay, thank you very much, Dovil, for your kind introduction. So the title given to me is Need-Led Innovation, why bother? And I'm trying to, if not exhaustively answer this question, give some thoughts to sort of process this concept further and hopefully get new ideas about need-led innovation. I'm not entirely sure that what is the precise background of the people attending this seminar, but I've understood that there are students and there are researchers, also people from companies. So I'm sort of trying to think about this when I'm talking to you. So I'm the project manager and the PI of the Biodesign Finland program, which is a joint program together with Aalto University, University of Helsinki, and Helsinki University Hospital, and Metropolia University of Applied Sciences is our partner. I'm not a neuro researcher, especially although I come from the Department of Neuroscience and Biomedical Engineering. But my sort of scope or viewpoint to today's discussion is medtech and biodesign innovation process. I will be talking about both. And since innovation is very or let's put it this way, since commercialization of medical technology is typically in the core of innovation, I will be talking about commercialization of medical technology as well today. Innovation is a big, huge word. Actually, it's very commonly used. In my opinion, sometimes misused or misunderstood. So that's why I sort of would like to define here how I personally see innovation and what is sort of the context and viewpoint to innovation when I'm talking today. So Oren Harari has said that the electric light bulb did not come from the continuous improvement of cancer. I think that this is very much in the core of innovation. I very much love the definition of innovation by Professor David Burkus. So innovation is the application of ideas that are novel and useful. Creativity and the ability to generate novel and useful ideas is the seed of innovation, but unless it's applied and scaled, it's still just an idea. So try not to think that idea is an innovation. Innovation is something more. It's of course new. It's based on an idea. It's something useful, beneficial. It's something that will be applied into practice and scale. So it's in broad use, and people who work with euros would like to add also to the definition of innovation that it's also commercially exploited. I'd like to exemplify what innovation is with this graph. So we have benefit as a function of time. These small steps here are something that I refer to as incremental innovation, so small improvements. Small benefits, and this big step here, would be a quantum leap, a major innovation, a major benefit to the previous state. I'm not going to talk about mobile phones today, but I like to use this as an example of innovation. It's not medical technology. but we see here a non-exhaustive rough timescale of development of the telephone. So this is not an exhaustive list. So there are many different forms of telephone and communication missing here, but I'm using this as an example. We think that Graham Bell invented the telephone, but actually he did not. Graham Bell was 11 years when telephone was invented. It was invented by Antonio Meucci, an Italian guy who eventually got bankrupt and died during the patenting process, process of the telephone, and eventually Graham Bell got the patents for his invention and made also some dollars out of it. We see different versions of telephone over the time, and we see different versions of the mobile phone. We could consider that a quantum leap took place not at the time of Antonio Meucci, because that was still sort of a prototype. It was an idea of an innovation rather than a real innovation. So when it was put into practice and scaled up, that innovation actually was taking place after the activity by Graham Bell, and maybe we could consider that one quantum leap took place when this kind of we went from landlines to mobile phones, and maybe one quantum leap took place when the smartphones were introduced, and direct object manipulation on the screen was possible. And I think that all this innovation is very much driven on the need of people wanting to communicate with each other, and everything started from Antonio Meucci. There are also other people who have very much contributed to the early phase of the telephone, but we see that maybe when we got to the mobile phone phase, the innovation was driven by the size of the devices, and later on the size actually became less important because the mobile phone is fulfilling some other needs of the humans. Now I'd like to jump to commercialization of medical technology. In order to understand the importance of the need-led innovation in the context of medical technology, I'd like to sort of talk about the timeline of commercializing medical technology. So this is not ideal timeline. First of all, I'm going to show that what's wrong with this one, but I wanted to show this because this is the time scale or a flow chart that is commonly presented in the context of commercializing a product. So this is from a consultants company. These boxes and the contents here. So you need an idea. You need to create an idea around which you start to develop some kind of a concept. You need to show feasibility that this concept is actually working. And when you are able to show that it works, you start to develop a product which is different from the concept. And eventually you need some kind of clinical evaluation to demonstrate that it works in the clinical context the way it should, and it's safe. And there's a regulatory process that is that needs to take place in order to get regulatory approval and get that product to market. Finally, when all this is complete, you get to the market launch phase, and you will work to make the market adopt your product. And since we come from the university context, the common route to commercialize this, it could be through the industry, but I'd like to talk about the startup route now. So you would have a pre-startup phase, a startup phase and a phase where you create revenue. Maybe you want to sell this technology to a bigger player, and it's actually not very easy nowadays to sell any concepts or even products to big companies unless you have shown clinically that it works and risk has been already mitigated. So from the idea to taking the product to the market, it takes about 3 to 7 years. For drugs, it can take 12 years. And throughout the process, you need investments. You start with small investments, your own money, angel investments. You move on to more like institutional investments and big investments over time. The risk is going down over time, and the investments are going up over time, quite typically. And you would expect to need something. This is not an exact number, but in the ballpark, you would expect to require 5 to 20 million euros investment to actually make a successful commercialization of the technology. But I'd like to state here that the only instrument you actually need here, to a little bit simplify, is a thread. But it's very difficult to push the product to the customer with a thread. But if the customer wants your product, it's much easier to make the customer pull using the thread, the product from you. And now we are getting to the core of today's discussion. So in order to make the market launch and market adoption successful, there has to be a concrete need. The customer needs to need your product, needs to want that product. And in order to get there, I would a little bit rework the beginning of this diagram, and I would like to start with the need identification, followed up by idea creation and concept development. And for the researchers, I'd like to tell that please take the need identification even earlier if you're working in the applied research. Maybe not that applicable to basic research, but if you're in the applied research phase, think about the need, and not superficially, but deeply, even before you select your research topics, because if some new applications come out of your research, it's better to actually address a concrete need many years later when that result becomes a product that the customers will adopt. So why is identifying the need so important? So these are maybe a little bit opinionated, so these are not hard facts, but I will share some of my thoughts why I think that why the need identification is so important. So once you get the company funded and you start running, you really cannot stop. The regulatory process is very slow and costly, so you cannot really start doubting the need once millions of dollars have been raised. What would the investors say if you have been working several years on a product and you start doubting that, okay, does the customer actually need this? So the changing of the need could lead to costly changes in the product design, and that is not really what the investor wants to hear. They can cut your project if they see that okay, the risk is too big for this product to become acquired by the customers. A medical technology commercialization expert that I have been working with told me that a common pitfall for medtech startup is that their need is not well validated. And he also said that they offered medtech startups a service to validate the need for their solution, but they refused. So it's very easy to actually believe so much in your idea that you become biased and you're actually creating a solution to an illusion of a need. you have very much you have a bumpy road if you go that route. So that's why I'd like to stress here the importance to think about the need and separate great idea from an illusion of great idea. I've done this mistake myself many times, and it's sometimes really hard to see that, okay, is this an illusion of a great idea or is it a great idea? So be very honest about yourself that is it a great idea or not? And think about the need. Is there a concrete need, and is the market ready to accept your innovation when you get to the innovation stage? So briefly about the biodesign. So how do we actually address this need concept? The goal of biodesign innovation process is to develop and establish new medical technologies to address unmet needs in healthcare. So addressing concrete needs out there. Biodesign innovation process was originally developed at Stanford University about 20 years ago, and it has spread from there all over the world. And in Finland, we have operated on an independent program, under an independent program, Biodesign Finland, since 2016. Organized by Aalto University, University of Helsinki, and Helsinki University Hospital, and Metropolia being our partner. And we have networked with several organizations and institutions. So how do our projects work in practice? So how do we take care of the need in practice? So we run this program on an annual basis, and we have projects on an annual basis, typically 1 or 2 projects per year. We recruit a team of 3 persons, typically 3 persons. Once we had 4 persons, and we train them. The people in the team come from different disciplines, for example, engineering, business, medicine, or design. We train the team for 1 month, and after that we send the team to the hospital to make observation, to observe problems from where the needs are identified. So about 200 to 300 needs are identified during a 1 month period the team spends in the hospital. This is quite exceptional. Not many startups have the opportunity to spend 1 month in hospital. So it's unique and very special. After the team has identified from these needs through a systematic process I will talk about in a second, they choose one need to which they start to invent concepts, prototype them, and develop strategy to actually commercialize that concept. And in the end, we expect to have new medical technology innovations, startups, and to have trained industry leaders in this field. So our project typically is 11 months, and how does the timeline look like? So there's a training period that takes 1 month, and after the 1 month training period, the team will be sent to the hospital, and they start to identify problems. They identify first problems, not needs. They identify problems. So they go after doctors, nurses, patients, follow them, talk with the patients' families, secretaries, etc., to figure out that what kind of problems there are in that environment. The height of this figure here refers to the number of items. So in the beginning, you don't have any observations of problems, but in the end of that immersion period, you have a large number of observations, 200 to 300 observations. And based on the observations, the team starts to identify needs and create need statements that define what the need is. We're not going to the need statement here. There's going to be competition analysis, team interest discussions, market analysis, and validation of that need. So interaction with the hospital personnel in order to validate that the need is there. This part is is somewhat similar or has some similarities with lean innovation process, where there is a sort of a fast feedback with potential customers. And here also there's interaction with the personnel to figure out that the need is actually there. But it's not only the customer need, but also doing reality check with the market status and competition status. Also some other criteria might be used. So using a certain scoring method, the team will actually narrow down the needs to just a couple of needs that they find that are the most important ones, and they start to create actually solutions for these few needs. There can be 2 or 3 needs or 5 needs in the end of this needs identification process. And they start to create solution concepts. So what kind of a concept could be, what kind of a solution concept could be created around a need to address that need? And one need can have several solutions. And in the end, they would, or eventually they would have several concepts out there, and using other set of criteria like feasibility, how difficult is it to actually create this technology, IP analysis, regulatory analysis, stakeholder analysis, and further validation. With these criteria or more, the team then identifies that which of the solutions has the greatest probability to actually succeed in the commercialization process, in the innovation process. And in the end, they would have only one solution which they start to commercialize. So prototyping, fundraising, this takes place in academia. And the team starts to raise funding for the follow-up activities, which could be research within the academia or starting a startup company right away. And this has been quite impactful so far. So 6 teams we have trained so far. So here are the pictures of the teams. Maybe some of you identify familiar faces. These teams have identified 1,400 unmet needs in the Helsinki University Hospital. 4 of these teams have been selected to the Stanford originating Spark Finland mentoring program. 4 of these teams have received research to business funding from Business Finland. 6 companies have been created by the Biodesigners. 3 companies have come directly from these Biodesign projects, Koite Health, SpectroCore, and EpiHeart. And they have already raised 3.6 million euros for these activities. The first product was launched this year in the summer, in June, by Koite Health, a Lumeral product for bacterial management of the mouth. And some more products by the Biodesigners have been launched already. We're obviously early days, and the innovation is still expected to take place, which means that it needs to be scaled and adapted by the market and the users all over the world. But I think that our early experience is very promising. The take-home message I'd like you to consider and share your family members and friends, hopefully, also, is that focus on need before anything else. You might have great ideas, but put them aside for a while. Think about the need, think about the need, think about the need in a deep sense. And after you deeply understand the need, think about the ideas. Then the ideas might have a future. This is all I wanted to share to you. When the time comes for questions and discussion, I'm more than glad to answer your questions. Thank you very much for your attention.
Okay, thank you, Heikki, for a great talk. So our next speaker, now I'm glad to introduce, is a Professor Risto Ilmaniemi, a great innovator, research group leader, and head of the department, Neuroscience and Biomedical Engineering, Aalto University. In his career, he has gathered a lot of experience in both sides, research and business. So welcome, Risto, and thank you for joining us today.
Okay, so I start. Well, thanks for this opportunity, and I will continue from what Heikki said. So Heikki is, of course, leading the Biodesign program, which is a collaboration between Aalto University, University of Helsinki, and the Helsinki University Hospital and Metropolia. So I will not introduce Biodesign itself. I'll show my screen in a moment. So NeuroBiodesign. I've been working in Biodesign together with Paavo Kinnunen. We started it several years ago, and in the last couple of years, I've been working as a representative of Aalto University in the preparatory group of Neurocenter Finland, and I was the chairman of the group. Talking about and planning for innovation activities within Neurocenter Finland, and we came up with this goal. This is a very ambitious goal, that making Finland number one in neuro innovation. So if Neurocenter Finland can do that, then that will be a great center. Of course, it will be many do other things as well. But we're talking about neuro-innovation. What does neuro-innovation mean? It means innovation in the field of neuroscience and neurology, medicine, basically things that solve problems or needs in regarding people's health, brain health, neuro health. And of course, as was mentioned already, we already have Biodesign Finland, collaboration with these four organizations. And so what does it mean, making Finland, how can one make Finland number one in neuro innovation? This may sound like an over-ambitious goal, but Finland has been very successful in many other areas. Why not here also? And we have a great we have great expertise in neuroscience. I know there are many excellent world-class groups in Finland. We have a great innovation system. For example, the SLAS conference is an example of that. Good funding. I think Finland is either number one or among the most attractive countries for startup funding. So this may be possible. At least it should be our goal. And what's step one? Well, I suggest it is NeuroBiodesign, because that's in a way the easiest to begin, because we already have Biodesign. And NeuroBiodesign is just a biodesign, but the topic is not any area of medicine or health. It's the neuro health. Step two would then be gradually to develop among people in the universities, in hospitals, neuro research, a new mindset. Well, not everybody has to have this mindset, but sufficient number of people with a new mindset that begins from these needs, as Heikki explained, and tries to find solutions and develop these solutions at step three to innovations. And innovation, of course, means some novel method or technique or idea or invention that will be developed into a product or service. So an idea is not yet an innovation. You have to develop it and make it available for the world. So the need, as Heikki emphasized, is the beginning. And we have a big need. The teams, of course, have to decide their sort of niche, small need, but we have the big need, reduce the burden of brain disorders. And this is really a huge need. And there are many problems people have. Different people have different problems. Depression is one of them. Dementia is increasing. Alzheimer's disease and other types of dementia. Stroke affects 15,000 Finns every year. Maybe 1/3 of them die because of stroke. Pain, chronic pain is also a big problem. There are many others. Many brain disorders, and they cost a lot of cost. They cause suffering, but there's also a great financial cost. It's approximately 1,000 billion euros per year in Europe alone. This is based on estimates made about 10 years ago. Well, more recent estimates make this number even higher because some of the psychiatric diseases are difficult to evaluate in terms of cost. It's probably much higher than that. But this makes about 2,000 euros per person. In Finland, it is approximately about 10 billion euros per year. So it's a big problem, suffering and money. And now, the Aivo Säätiö, the Brain Foundation of Finland, I heard that they have a goal of reducing the cost in Finland by 10% in about 10 years, and that make already 1 billion euros per year. So it's big money, and therefore it's a good idea to invest to solve the needs. So if we analyze the needs a little bit in more detail, prevention of disease, the prevention of brain disorders, well, maybe in these corona times, mental problems, how to prevent depression and other agonies. Also, brain health, nutrition, to reduce the risk of stroke and other diseases. So this is one thing that can be addressed. Diagnosis, early diagnosis for Alzheimer's disease and others is extremely important. Cancer and everything should be diagnosed early and reliably. Treatment, then once you have done the diagnosis, people should be treated. There's a lot to do there. Therapy. Now, in all of these cases, when the biodesign works, people go to the team goes to the hospital or medical center, or maybe to other places as well, to make observations of how things are done, and then define the niche need. Well, there's need for cure. And then don't forget that the need is not only among the patients, it's also the family and friends. They are also affected. So innovation may also be in the range, in the area between the patient and the family. Because often family will have to treat the patients when they come home. Well, NeuroBiodesign, some pictures here to give some idea that it's a very versatile thing. There's people in the hospital, like in the lower picture, in the intensive care. There's neurosurgery. There's diagnostics, prescribing medicine, doing neurostimulation with TMS, diagnosis with EEG. And then there's therapy, for example, for dementia people with memory disorders and after stroke, for example, rehabilitation. Taking care of old people with limited mental abilities and so on. So some words are listed on the left. I don't need to read these. Well, maybe the one in the bottom, the remote rehabilitation and self-treatment. This is an increasing area of the practice of neuromedicine or rehabilitation. So people go home. They have some devices there. They at least have the mobile phone or maybe a computer, and they can be in contact with the medical experts via these techniques, and they may have some instruments also to make diagnosis. We already have the thermometer at home, but we can have other things as well. Okay. There's a lot of place for innovation in the remote treatment, diagnosis, and rehabilitation. Everywhere. NeuroBiodesign. So we are now discussing, actually, with Helsinki Hospital, the city of Helsinki, whether we might be able to begin the first NeuroBiodesign already next year. And then I hope that the following year, the Neurocenter Finland would follow in different cities, Helsinki region and the capital region, Turku, Kuopio, Oulu, Jyväskylä, Tampere, and mainly the university hospitals, but other regions also may begin NeuroBiodesign projects. I hope that will start in 2022. Well, a couple of slides still. I want to say something about the NeuroBiodesign key for success. This is actually the same for any biodesign. The key thing here is the team. It's in all business, all startups, all operations, but especially here, the team is extremely important. That defines the success. And what we want is 3 to 4 highly motivated individuals with diverse background and open mind. So diversity is important. The different people in different backgrounds, different ways of thinking, but they have to be able to work together and appreciate the fact that people are different. This is the strength of a good team. Diversity and they must want to change the world and also their own life, because NeuroBiodesign is not an ordinary project. Like in the universities, we may have an idea, we get the grant, and when it ends, then we go to another project, and that's also very important. But here, it's really, for many participants, it's really changing their own life. Some of them quit, resign from their old safe jobs, and come to this biodesign team for 11 months. And there's no future after that unless they succeed. So it's a big challenge. But they really have the motivation. They have to have the motivation to change the world for the better. And they find the need, as Heikki described, and then try to solve it. So some types of people we want: healthcare professionals, engineers, scientists, physicists, chemists, materials experts, entrepreneurs, inventors, software architects or programmers, designers, artists. So usually, perhaps always, we want to have one healthcare professional, medical doctor, nurse, and then a technical person, because usually the biodesign solutions are technology-based. It could be also a service, but usually there's an engineer or physicist, chemist, materials expert. And then it would be useful to have somebody who has a startup state of mind, or entrepreneur state of mind, and or designer, or even artist. Can be a designer from a completely different area than medicine. And then one important thing is that no background is expected in neurosciences or neurology. Even the medical expert should usually, it's not, I think, that doesn't need to be a neuroscientist or neurology expert or neurophysiologist, or can be oncologists or general practitioner, but medical background is useful. Useful for this person, but no background in neurosciences, because the needs are often practical, and where the hospitals already have the expertise in the specific fields. That's not needed. What's needed is something new. Okay, I just want to show these teams that we have had. In one of the pictures, there are 2 teams. There are 6 teams here that we have had in biodesign. Heikki already showed this picture. So these are just wonderful teams, all of these. This is the key. We have been extremely lucky of getting great teams, and this is the key. So the team will define, I think this is the final slide. So the team will define a need. After making observations and thinking for months, they will define a need, one need. They will solve the problem, and then they will deliver the solution to the world. This is biodesign. So recruitment for Biodesign Finland 2021 will start in November. So it's a great opportunity. It's very challenging. But this is the way, I think, to start making Finland a great neuro-innovation country. Okay, thanks.
Okay, thank you, Risto, very much.